Okay, bear with me because while I'm pretty good with numbers, less so with content creation. Okay, so in reviewing the data set that was provided in the CSV file for the power plant, and knowing that I'm going to be using Microsoft Excel to perform these regressions, I decided on a linear regression, and specifically one doing a k-fold methodology. So specifically, I ultimately broke the data set up into 70% of the rows being used for the training of the model, and the additional 30% being used as the testing for the model at the end. Within the training data set, I broke that up into 5 folds, so k equals 5. It's roughly 1,300 and change rows per fold, using those same 4 independent variables, so pressure, temperature, all of those, to find our independent variable. Reverse those dependent variables to find our independent variable of energy output. So using a couple methods, I was able to break those tables up and perform a regression using some of the data tools in Excel. That automatically outputs a slew of data, but the useful bits for us were the R squared, as well as the intercept for the formula and the coefficients for the 4 variables that we had opted to use. So I performed that for all 5 of the folds individually, took an average of all of those, and what that allows you to do is just to make sure that your predictive model and the methodology that we chose was relatively uniform across them. They don't need to be identical, but as long as they're ballparking close to each other, then you know that it's not getting skewed by any chunks of data that are wacky. So once we established that it was a viable methodology moving forward, went ahead and finished the rest of the model building. So the next step was to then take that same methodology and apply it to the entirety of the training data set. So no folds involved there. Once that was done, we had gotten coefficients and everything else, all the R squared, mean average errors, mean of sum error, mean squared errors, and had all of that prepared for the full data set, and comparing that again to the fold average, was able to officially say, yes, confirmed, this model works, the regression itself gives us a decent output, and it has, I think it's a 93 and change percent practicality. The R squared is 93 and change. So once that was established, I used that same intercept and coefficients for the given variables and applied that instead to our testing data set, so the remaining 30% of the original data set. After performing all of that, I was able to get the mean average errors, the mean squared errors, and then manually calculate the R squared by manually calculating the TSS and the RSS. In doing so, I was able to establish that and evaluate the model and establish that it was a fairly accurate predictor of energy output given those provided variables like pressure, humidity, temperature, all of that. So high-tech stuff here. What you can see here are the metrics for relevance for fold 1, 2, 3, 4, 5, the average of the folds, the outcome of running it on the training data set in full, and then the same thing with the testing data set in full. So our R squared overall is about 93 with the unknown beta, which is roughly in line with the 93 R squared that we had for individual folds on average and the training set. So the interpretation of the model is that it's relatively accurate, not perfect. I think you'd like a slightly higher R squared if this were something you were going to try to use in a practical sense, but at the very least, using a linear regression with k-fold methodology was able to establish that this model is maybe ever so slightly under anticipating the energy output given any circumstances of temperature, humidity, all of that. Thank you very much.